All right, it's time to get into some nitty-gritty stuff, the fundamental theorem of calculus, specifically part 2. So if f is continuous on a closed interval from a to b, then the integral of f of x from a to b would be f of b minus f of a, where f, capital F, is any antiderivative of f. So I don't know if you remember, but with the triangles and whatnot, we found the exact value of this integral, and we found it to be 1.5 by means of using the areas below and above the x-axis. Now let's verify it using the fundamental theorem of calculus. So the integral from 0 to 3 of x minus 1 dx. Remember what I'm doing is I'm going to take the antiderivative. So this is already x to the 1, so I'm going to add another 1 to it, so I get x squared, and then I divide by the power, and then minus. And then the antiderivative integral of 1 is going to be x, because it's like saying 1 times x to the 0, just the regular one, and then if I add a 1 to it, I get, well, that's my minus sign, I get x to the 1 over 1, but I don't need all those 1s. And now, with the fundamental theorem of calculus, I need to evaluate that from 0 to 3. So remember, I do the integral, the antiderivative of fb, and I subtract from it the antiderivative of fa. So that's what I'm going to do. I'm going to plug 3 into these values first. So I'm going to have 3 squared over 2 minus 3. And I'm going to subtract from that 0 squared over 2 minus 0. And this is going to give me 1.5. Next, let's use the fundamental theorem of calculus to evaluate the following definite integrals. Or if it doesn't exist, let's state that it does not exist. All right, so taking a look at this one, we think to ourselves, okay, what do I take the derivative of to get 1 over x? And yeah, that would be the natural log of the absolute value of x. We need that absolute value in there. Mind you, if we did x to the negative, if we thought of this as x to the negative 1 and we tried to use the power rule, we would get x to the negative 1 plus 1, which gives me 0, and then I would have to divide by that power. And so what we have to remember is that if I have 1 over x, then I'm going to have the natural log of the absolute value of x. Okay, and I don't need to do the plus c because I'm evaluating it from 1 to 5. So let me go ahead and plug that in. I'm going to have the natural log of the absolute value of 5 minus the natural log of the absolute value of 1. Well, 5 is already positive, so this would just be the natural log of 5. And then the natural log of 1 is 0. So natural log of 5 minus 0 is just the natural log of 5. For this one here, letter B, we don't have a rule. We don't have a power rule yet, we don't have a product rule yet for integration. You'll get there. We actually won't get there in this class. You'll get there in the next class, and it's called integration by parts. However, since we don't know it, what we need to do is write everything in a form that we could take the antiderivative of, take the integral of. So we're going to FOIL it. Okay, we're going to FOIL it first. 3u times u is going to give me 3u squared. 3u times 1 is going to give me 3u. Negative 2 times u is going to give me negative 2u. Negative 2 times 1 is going to give me negative 2. And then this plus 3u minus 2u is going to give us a plus 1u. So I'm just going to write in the plus u and then this minus 2. All right, this is what I'm going to take the antiderivative of. So remember, the 3 goes along for the ride. And here I've got u to the power of 2 plus 1, and then I divide by that 2 plus 1. And then here I've got u, which is already to the power of 1, add 1 to it, and divide by that power. And then here I don't have a u, I'm just going to add a u. And then this is going to go from -1 to 2. So I'm just going to straighten up, clean up house. This is good. The 3's are going to cancel, and I'm just going to end up with u cubed plus u squared over 2 minus 2u. Evaluate that from -1 to 2. So I'm going to do the 2 first. So I'm going to have 2 cubed plus 2 squared over 2 minus 2 times 2. And then I'm going to subtract from that because we always subtract in the fundamental theorem of calculus. And I'm going to have -1 cubed plus -1 squared over 2 minus 2 times -1. Now, if I combine all those values correctly, I'm going to end up with 4.5. All right, I'm getting sick of this red color. Yes, let's do some trigonometry. Okay, fundamental theorem of calculus coming your way. So think to yourself, because we got to take the integral of this. What do I take the derivative of? What do I take the derivative of that gives me this piece? What do I take the derivative that gives me this? Yeah, the secant. Okay, so this is going to be the secant of theta, and we're evaluating that from 0 to pi over 4. By the way, if you don't remember this stuff, it is really helpful to know your derivatives in order to do integrals. So anytime a student's like, I'm really struggling with antiderivatives or integrals, the first thing I do is I ask them if they know all their derivatives. And let me just kind of talk about why that's the case. Like, using a different example. If I know that 4 plus 3 is 7 and I have that memorized, I can use that fact so that when I do 7 minus 3, I can get 4. Or 7 minus 4 to get 3. Just make sure you know your facts. Use flashcards or something, okay? That's pretty important. Okay, so anyways, let's evaluate. Sorry, I had to interrupt to admonish you to memorize your derivative formulas, because I feel that people aren't memorizing them. All right, next, I just need to do the secant of pi over 4 and subtract from it the secant of 0. And then that's going to give me the square root of 2 minus 1. Now, if you don't know these off the top of your head, keep in mind there's this fabulous thing called a unit circle. And we just need to remember that the secant of pi over 4 is the reciprocal of the cosine of pi over 4. So, answer. Next one. Ooh, okay. This one might not look like what you're looking for unless you move the 4 outside. All right. I'll give you a second to think about it. Give you a second to think about it. Remember, the derivative, with respect to t, you're saying to yourself, the derivative of what gives me 1 over t squared plus 1? What's that rule? What derivative gives me 1 over the t squared plus 1? Do you remember yet? Do ya? Do ya? Do ya? Well, if you did, I'm super proud of you. It's the inverse tangent of t. And the 4 just goes along for the ride. So here I'm going to do 4 times the inverse tangent of t as t goes from 0 to 1. And then I'm going to do the fundamental theorem of calculus. And I'm going to do 4 times the inverse tangent of 1 minus 4 times the inverse tangent of 0. So this is going to give me 4 times pi over 4. Then here I'm going to have 4 times 0. And that just gives me plain old pi. Let's look at another concept. So here we've got the integral of sine of x, and we want to figure it out from pi over 4 to 5 pi over 2. First thing they want us to do is graph it. So here is our little pi over 4. And if you look here, we've got this piece, and then this goes all the way to 5 pi over 2. All right, so they want us to find 3 definite integrals for the regions bounded by the curve and the x-axis. So in other words, in between the curve and the x-axis, they want us to find this area here, and then they want us to find this area here, and then they want us to find this area here. We're then going to evaluate each definite integral and then use it to evaluate the integral from pi over 4 to 5 pi over 2 of sine of x. So let's look at this first one. So the limits for this first one go from pi over 4 to pi. So this is going to be pi over 4 of pi, 2 pi of sine of x dx, because that's my curve. This one here goes from pi to 2 pi. So this would be from pi to 2 pi of sine of x dx. And then this one here goes from 2 pi to 5 pi over 2. So this goes from 2 pi to 5 pi over 2 of sine of x dx. All right, now they want us to evaluate each one. So I'm just going to write out pi over 4 pi sine of x dx. Let's remember that the integral of the sine, right, which is the opposite, you're saying the derivative of what gives me a positive sign. Well, that's the negative cosine. And this is from pi over 4 to pi, which would be the negative cosine of pi minus a negative cosine of pi over 4. And then that one gives us 1 plus 1 over root 2. The second one here, and I go from pi, whoops, I can't write down that low. Whoops, woo. I don't know what I just did. Let me see if I can get back there. All right, for the next one, I've got sine of from pi to 2 pi of sine of x dx. And the integral of sine, positive sign is negative cosine from pi to 2 pi. So I've got the negative cosine of 2 pi minus the negative cosine of pi. And that one's going to give us negative 2. And then this last one here, from 2 pi to 5 pi over 2 of sine of x dx. Again, I'm going to get the negative cosine of x as it goes from 2 pi to 5 pi over 2. And then I'm going to have negative cosine of 5 pi over 2 minus a negative cosine of 2 pi. Oops, can't squeeze that in there on the edge like that. Doesn't like it. All right, and that one, again, with the aid of a unit circle is going to be 1. All right, I'm getting kind of low here, so I'm just going to do it up at the top. For D, they want us to evaluate this integral and interpret it as a difference of areas. Well, this integral goes from pi over 4 to 5 pi over 2, so that means I'm going to add all of these areas together. And they're not looking for the total, they're looking for the actual area, but keep in mind one of them's negative, so it is going to be subtracted. So I'm going to have 1 plus 1 over root 2 for the first part, and then I'm going to have plus a negative 2 for the second part, and then I'm going to have plus 1 for the third part. And when I add all those together, I get 1 over root 2, or root 2 over 2. All right, that is it for 5.3. It's short and sweet. Make sure that you have your derivative formulas memorized so you can do the fundamental theorem of calculus. Trust me, I only lied to you about arithmetic, right? Okay, good luck. You got this.